All right, it is exactly 6:30, so let's get started. Hello, everyone. This is a rather large room for everyone, so if you want to move over closer to me, that's fine. If you want to stay far away, because I'm the speaker and you're the audience, that's totally fine too. Thank you for coming this late session at Build. It's all day, all night. When my coworkers heard what time the session was, they thought it was a typo, but that's how we roll at Build. Raise your hands if you're drinking lots of caffeine in order to stay awake. Oh, good. If you guys fall asleep, I'm going to blame you. The rest of you, I will try to be entertaining enough so that you don't fall asleep. So my name is Donna Malieri. I'm a program manager on the Azure mobile team. And you can reach me at LinnyDonna on Twitter. And I guess you're supposed to look at the QR code in the beginning of the talk. So what I want to talk to you today is about Azure mobile apps and what that means. Particularly, I'm going to talk about what Azure mobile is in the context of App Service, which is a new offering that we've come out with very recently. Can I get a show of hands? How many of you have attended at least one breakout session on App Service? Not a ton of people. So if you want, I recommend you go back later and watch the recordings. Scott Hanselman and Scott Hunter did an excellent presentation, and Wade Wegner also did one. So I'll talk to you about what that all means and how it all fits together. And I'll talk to you about what that means for mobile. Basically, what Azure mobile apps is the next generation of mobile services. And I'm going to talk about how you as developers can use that to build both consumer apps and enterprise apps. So some of these scenarios may not exactly fit the kinds of apps you're trying to build, but I want to show you an end-to-end system, and then you can fill in the blanks with how you might actually do things for the projects you're building. In particular, I'm going to talk about offline sync. It's not limited to enterprise apps, but the particular example I'm going to use is an enterprise app. So, App Service, what is it? It is an integrated offering that gives you 4 components. So the first one is web apps, which is basically Azure websites rebranded with some new features, of course. The reason they did this rebranding is because Azure websites was actually an excellent platform for hosting code, not necessarily just websites. So that's the reason for the name change. And there's a lot of really awesome new features that have come out for Azure web apps. The cool thing about App Service is that all of these other components can now use all of those features. Because I'll explain, the hosting environment is actually shared. So mobile apps, you can think of as mobile services platformed onto App Service. And I'll explain exactly what that means and go into the code and show you the portal and everything. But that's the basic idea. Logic apps, you might remember a brief demo of that Scott Hanselman did in yesterday's keynote, where he had a kind of visual workflow editor in a website, and then he made his little Channel 9 action figure. So that's what Logic apps is. Logic apps is about orchestrating multiple pieces of your system together, so business processes. An example would be that a customer sends an email, and then you have an automated system that puts it into your CRM. And API apps are kind of the glue that connects everything together. You can build an API app that's custom, or you can use one of the connectors that we have in the gallery. So for example, there's Salesforce, there's SQL, there's a bunch of enterprise connectors, and then there's a lot of social ones like Twilio and Twitter and things like that. But of course, you can submit your own API apps, you can add them to the marketplace, you can also host them privately. So it's really opening up a lot for people. So in terms of the platform view, you can think of API apps and mobile apps as running, actually, you don't have to just think about it. They do run on web apps. And Logic apps are for orchestrating all of these components together. So what this means concretely for mobile services customers is that you have more control. So can I get a show of hands? How many have played around with mobile services or are familiar with it? OK, so a lot of people. Awesome. Great. So I can explain to you exactly what's different between Azure mobile apps and Azure mobile services. So as I said, App Service is about kind of expanding what you can do with this offering. Another great thing with it being a common hosting environment is that now you have one billing model for all of your app services. So for instance, let's say you have a website that gets a ton of traffic, and so it needs a lot of capacity. And you have mobile apps that take advantage of offline sync, and so your clients aren't very chatty, so you don't need a ton of compute resources. If you want, you can host those two together and decide to scale them together, or you could split them up. And now with the new dedicated scale unit offering in Azure App Service, you can take advantage of that for all of the app services. So you may have noticed the word app and services appears a lot. So you can keep count if you want and tell me at the end. Another important part is that there's a gateway that's a part of API apps technically, but all the app services take advantage of that. And that means that now you have one common place where you do your authentication. So I'm going to show an example where we're authenticating with Salesforce, and we're actually going to do ad hoc federation with AAD, and we can use that same exact gateway to authenticate users of our web app and users of the mobile app, or I should say the service behind the mobile app. So now, why is this all interesting? I want to tie this all together in a story. It's not the most exciting business in the world, but I think what they're trying to do is pretty cool. How many here have heard of Fabricam? Fabricam, you know about Fabricam, right? Yeah, Microsoft loves Fabricam. And Fabricam loves Microsoft. And they are recently under new management, and they've decided to relaunch their cable business, Fabricam Cable. And they took a look at Azure App Service when it launched a month ago, and they said, oh my God, this is perfect. This is how we're going to revitalize our business. I don't know about you, but my cable company gives me a 4-hour window when they're going to repair things. Has anyone had that experience at all? And even when they do come, they don't fix it, and then you have to get on hold with customer service, and it's just a giant mess. So Fabricam Cable is in a market where there's a lot of competition, and they're able to kind of do a whole new business model for customers. And that's how they're going to, that's why they're going to use Azure App Service to change the way they're doing business. So first off, they're going to do online appointment booking. They're going to give you push notifications and SMS alerts when the technician is going to come to your house. And then they're going to do a revolutionary 10-minute service window. And they're even going to send you push notifications when the technician is on the way. And the technician will use a mobile app. It will all offline sync. And the goal is for Fabricam Cable to provide an excellent customer experience. Now, you may not be working on a big enterprise app, but the same scenario applies, even in a small business. You have a lot of components that you want to integrate together. Maybe those are third parties, some third-party CRM system you've purchased, or maybe they're internal APIs that you've purchased. You need to orchestrate between all of these. So let me talk about how this scenario is using all the components. Basically, the customer is going to book an appointment on a new website. There's an existing website that the customer valet is going to use to assign a technician. So this is one of the ways in which they're differentiating themselves. It's not customer service, it's a customer valet. And then the service technician is going to use a mobile app on their device, and they're going to be the ones that close out the work order. But all of these things are going to be orchestrated together so it works really seamlessly, and they can ensure a good customer experience. So what I'm going to do is show you a logical view of this. And as my talk progresses, I'm going to fill out the architectural diagram that maps to all of these pieces. And I'm also going to show it working end to end. So there's an existing site that's for the customer valet. It's actually used for many different aspects of Fabricam for doing service advising, and scheduling work orders, and that kind of thing. And now they've built a new customer site where customers can see what the available appointments are. They can choose a time slot that will get added to a CRM database in Salesforce. And now the customer valet is going to look at these new appointment requests and assign technicians to them. And we're going to use logic apps to send the customer a notification when their service has been scheduled. Then there are two mobile apps. I'm only going to show you one of them, but you can imagine what the other one will look like. I'm going to show you the technician app. But in these scenarios, there's often a corresponding customer app. And that's what the customer sees when they say, oh, your appointment has been scheduled, or your technician will be here in 1 minute, that kind of thing. And to tie all these things together, we're going to use API apps. So these are just some of the connectors we can use. So Office 365, Twilio, Salesforce, there's also a Dynamics connector, there's HTTP, there's SQL, and of course you can write your own. The great thing about the connectors, as I said, is that they can have authentication in them and access control in addition to providing an API to the different components of your app. And also, we often hear the word app when talking about app service. The term is slightly overloaded, which can be a little confusing. When we say you build an app with app service, think of it as an end-to-end solution or an end-to-end system. And obviously, it's going to use more features in Azure than just those in app service. So think of app service as this common compute layer, and your app is basically an end-to-end solution, which not all of it needs to be in Azure. And you use app service to help you build that out. So I'm going to show you the first few pieces of this. There's going to be a customer app. The customer valet is going to use a web app to create a case in CRM, and the logic app is going to send a push notification. So let me switch to my demo machine. Oh, the computer went to sleep. It's conserving energy. OK, so this is the new site that customers will see that shows them the availability of what they can schedule for their service technician. And look, this is another revolutionary thing. They have Sunday appointments. So what I'm going to do is I'm going to request a Sunday appointment for my manager. He couldn't be here today, so I'm going to help him out by sending him a service technician. And that will, I won't show all the details, but that's going to go into the CRM database. Then what's going to happen is the customer valet is going to see this site. And you can see it's shared among other Fabricam assets, because this is, for instance, the Fabricam Cars website. And that was entirely intentional on my part, of course. And what I'm going to do is, since I have an in with the customer valets, I'm actually going to schedule an appointment for myself instead. The one thing I forgot to mention, Fabricam, since they know Microsoft so well, they're going to roll out a VIP service to Microsoft executives and employees in Azure. So we see Scott Guthrie is in here, my VP, Bill Staples, and some members of the Azure mobile team. And so that's how they're going to really prove out this amazing new cable system. So what I'm going to do is I'm going to request. So I've previously filled out that web form, requested service. And so now the customer valet will see this. That is Carla Davis. And now I will click Next. I will choose a service technician. This one is good because he is a cable repair person / oil and transmission specialist / actor, as you can tell from his headshot. So what I need is my cable box updated. So what I'm doing now is I'm dragging an appointment onto Bob's calendar in Office 365. And so he will see that there. And this will also get synced to his mobile device when I show you that part of it. OK, so that's all set up. And if the demo gods are kind to me, then what we will see is a push notification. We may not. But there is, in fact, a Fabricam push app. Oh, it worked. Awesome. So I actually clicked that a little too fast, but it said appointment confirmed. So basically, it used my identity to send a push notification to my device. So I said I wasn't going to show you the consumer app, but I did show you the push part of it. And it looks like Kirill cannot have service because the site didn't like him. But it's OK, because I'm all signed up. Now, I'm not going to show you the Azure portal just yet, but I'm going to show you, and this is the Salesforce database. Let me refresh this so you can see that the data did indeed get saved to it. And so here is the new case that I created. And I'm not going to show you all the details, but this is actually using Active Directory federation, using kind of an ad hoc federation model with the gateway. And it's all rather involved, but this is actually a custom Salesforce instance that is synchronized with an AAD tenant called Contoso Web. So let me show you a screenshot of the Technician app, because I'm going to actually dive into the details in a minute. And this is written using Xamarin Forms. It was not built by designers, so this is the UI that we had. But we were able to build it very quickly because Xamarin Forms lets you define a UI once in your code and basically have a ton of code share between your different apps. So this app, for instance, works on both Android and iOS and integrates with device functionality. And I'll go into great detail within this, and I'll even show how the offline sync part of it works. A little bit about push notifications. Actually, let me see how many of you already know this. How many of you are familiar with Azure notification hubs? OK, a lot of people. I'll just summarize the slide quickly. Basically, whether or not you use notification hubs, you need to request, you as a developer of your app, need to request a device handle from the platform notification service. So that will either be, say, the Windows notification service, the Apple one, or the Google one, or Baidu, et cetera. The problem is, unless you have a service like notification hubs, you as a developer in your backend, you need to maintain a mapping between these device handles and logical users. And if you have logical groups, it's even worse. Then, if you want to send these notifications, you have to manage the scale yourself. Basically, you can't. You have to build a scalable backend service that can send thousands of or millions of notifications a second. And what Notification Hubs does is that it basically does all this for you. And it scales really well. It was used in the Sochi Olympics app and a lot of other places. So that's the benefit of Notification Hubs. And that's where that was the piece I used Notification Hubs to send myself a notification. And in my backend code, I didn't even have to care about the device handle. I just registered, as a developer, I registered the logical user of the app. And then in the backend, I just sent a notification to that logical user. So to tie this all together, let's look at some examples of how people are currently using mobile services and how they can continue to do more with them. So when it comes to consumer apps, Sleeve Music is a really awesome app. It's available on Windows Phone, so if you have a Windows Phone, try it out. It's an app for helping you discover new music that you might be interested in. And in particular, if the artists are local to you, they've just added a new social feed feature, which uses the new API apps Twitter connector in order to help to get users to subscribe to a feed or to show them a custom feed. So it's about engaging with artists. And the way that they were able to do all this is, it's pretty hard to do all of that in your client app, particularly if you want to make it multi-platform. So using a service that handles this for you really eases a lot of the burden. Another example, this time a business app, is 3M. So they had this new parking meter product that they wanted to sell. And the salespeople wanted to know more about where these meters were installed and how efficient they were, but they actually had no visibility into that because it's a parking meter and it's located in a parking garage and there's no internet connectivity. So there was a lot of manual entry. And so the business owner was mentioning this to a dev at 3M named Jason Fox. And Jason's like, oh, well, I've used mobile services before. I bet you I could build this in a weekend. And then he immediately got worried because he'd set himself up for such a great thing that he had to do. But he did build it in a weekend. He used Xamarin Forms and Azure Mobile Services offline sync so that the app can now work offline in the parking garage. Because I don't know about you, but I have never been in a parking garage that had any kind of connectivity whatsoever. And you can do even more. And this is probably, you're all devs. You probably can think of other ways in which businesses can be revolutionized. But this is another cool story. Skanska, who is in the construction industry, had a construction site that they were building next to a hospital. And the hospital had a neonatal care unit, which is very sensitive to vibrations and dust particles. And so what Skanska did was they built out some sensors and connected that to Azure and used mobile push notifications so that construction workers and also the hospital administrators could see exactly what was going on, because they wanted to, they didn't want to cease work altogether because it's a construction site, they need to build things, but the jackhammers, et cetera, can cause dangerous vibrations. So this let them do their work efficiently and safely. Not to mention it saved time, because then the workers didn't have to constantly go and check meters. Now the information is getting pushed to their phone for them. So that was about mobile services. And I said the new thing is Azure mobile apps, so what's the difference? And fortunately, a lot of you are familiar with mobile services. So hopefully this diagram is familiar to you. Basically, mobile services gives you 3 core features, which is the data connections, user authentication, especially the kind that's plugged into your mobile device, so social login with a client flow where you get a nice UI within your app rather than getting redirected to some web page, and push notifications. And the other relatively newer feature is offline sync, which last year at Build, when I presented, it was still in preview, and now it's generally available for a lot of our platforms. So Windows Universal, Xamarin iOS, and Xamarin Android, and iOS native. And we're working on building it out on more of our platforms. Now, the thing that's different, aside from the data connectors, let me go back one. The data connectors are also different. See how I have API apps here? Now there's more opportunities for you to connect your backend to different systems. And the key there is the gateway that's in API apps. Now you can do some federation and ensure security when you're connecting to other systems. So what's new from a backend perspective is now your backend code is running as an Azure web app. This is the thing that mobile services customers have been asking from us for a very long time. Mobile services abstracts away your compute container, which means that it lets us do a lot for you. We can do a lot of monitoring, we can do a lot of scaling, we can basically manage things and give you a layer of abstraction. But what we heard from customers was, I don't want this abstraction. I don't want to work on a VM, but I also don't want something where I can't even control the fine-grained size of what VM I'm using, or how much memory I have available, or load balancing across multiple systems. So what we did for Azure mobile apps is to make your backend code run as a full-fledged web app on what's formerly known as Azure websites. So that means you get all of those features for free. In the past, every time websites added a new feature, and they were constantly doing this, by the way, we had to implement it ourselves. And now, every time they add new features, they've been adding even more. Most recently, you get those too. So I'll have a slide. Oh, yeah, so here is the slide. This is just a small list of the benefits that you get on Azure web apps. But a lot of people asked for traffic manager, geo-distribution, custom CNAMEs, VNet, and VPN, in production A/B testing, all of these things. What this also means is that if you can watch any of the recordings of Build Talks, because most of them have already happened. And if they're talking about Azure websites or Azure web apps features, all of that applies to your mobile services backend code. So for instance, David Ebo had a great talk on DevOps and kind of doing a whole flow with continuous integration and pushing new code and having it deployed. You can do in production A/B testing where you send part of your traffic to some customers and not others. All of those features, all of those use cases apply in Azure mobile apps. So right now, mobile services is only available in the Classic portal. And it supports both Node and .NET backends, as you know. Mobile apps right now only supports the .NET backend through a server SDK. Node support is coming. Once we GA Azure mobile apps, we will have all of the features of mobile services, plus many more. And at that time, you can choose what you want to do in terms of migration. So Azure mobile app is still in preview. What this means is, A, you should try it out, because this is when you can influence the product. And B, it's a new product, so it's a little rough around the edges. But we still want to hear the feedback, because we want to fix those most painful things as soon as possible. The new features are going to go into mobile apps, especially because we have this much more capabilities now that it's hosted on Azure websites. But however, Azure Mobile Services is still fully supported. Your sites aren't just going to go away. We're not going to kick you off. We're going to give you a seamless migration experience once we make our product generally available. At that point, you can decide whether or not you want to move. So we're going to just offer you a carrot to move. We're not going to kick you out. So if you have an existing app that's in production and you're not planning on changing the back-end code very much, you might decide to just stay on mobile services. But if you're making tweaks and you're like, oh, hey, I'd really like to use a bigger VM, or yeah, I want to use this new dedicated app service environment, at that point, you can seamlessly migrate. So let's go back to the Fabricam cable example, and let me fill in the mobile app backend part of it. So we already showed this part. A new piece is that we have a web job that is going to synchronize the CRM data, that the customer cases, to a custom SQL database that's specific to the Fabricam cable system. So you could think of that database as having more information than just the customer data. So for instance, it could have asset information of which cable boxes are given out to which customers. It can have a repair history for a customer. You can do all kinds of analytics and reporting on that. So you typically will have some kind of database like that. But you do want to synchronize it with your customer relationship data. And the mobile app backend is going to read data from SQL and then write changes through to CRM. So that ensures that when you close a case, for instance, it gets closed in CRM right away. The cool thing, though, is that now that mobile apps runs in the same container as web apps, is that this web job can actually run in the same exact container, the same exact site, as the mobile app. And I'll show an example of how that's working. I have it all working in a mobile app backend. And now it is time for the demo. Let me switch back to my Windows machine. So first, what I want to do is show you the Azure Preview portal and explain to you all the pieces that's in Azure mobile apps and kind of how that maps into what you already know about in Azure mobile services. How many people here have played around with the Preview portal? Some, not everyone. OK, so the Preview portal has a bunch of nice features. One is that you can pin given services to your start board. So here, this Field Engineer Lite is my mobile app. And this is really the blade that shows all of the components of your backend together, all the mobile-specific components. And so here, for instance, I have a gateway. And that was the API apps gateway that I talked about earlier. Of course, there's a notification hub. Let's see, this is actually too big. There's a notification hub. There's your master and application key. And then there's user auth. Notice how here in the user auth, there's this long GUID. It's because the gateway currently generates a very long GUID name for you to make sure it doesn't conflict with anything. But when you click user auth here, it's actually going and changing your gateway settings, which means that now when you have a web app that's hosted on the same, in the same resource group, it can take advantage of those same authentication settings. Now, the really cool part is that you can go to the code site now, and it's a full Azure web app. And so I turned on always on, so you see there's a bunch of requests. And at this point, I can go to all of my settings. So here I'm going to go to the web jobs part. And so this is the web job that I have running on that same subscription. And I'll show you the code for that in a minute. The other thing is that If you go back to the mobile app blade, you see this Add Client button, which is similar. It actually goes the same place as this Quick Start button. And that's basically similar to the Quick Start experience that you have with mobile services today. And you can see we don't have all of our clients yet, but we will very soon. We're adding more and more, and we welcome your feedback on all of them. So let me show you the code. So now I want to go to Visual Studio and show you the backend for that service that I just had. So I have this Field Engineer Lite service, and what this does is it gets deployed to that code site that you saw, and it has basically the mobile app name with a .dash code appended to it. So I've already published this, but if you want to see what I'm talking about, oh, I guess I haven't published on this machine. But what I would do to publish, it's a good opportunity to show you that, is I would pick Azure Web Apps as my publish target. Then I would sign in with my Azure credentials, which I'm not going to do now. And then it would show me all the web apps that I have on my subscription, and I could choose to publish to those. All right, so as you saw, there was a web job in there, and also the mobile app backend. The mobile app backend code is actually using some NuGet packages that we call the .NET Server SDK. And those are really similar to how mobile services worked in the classic world. Basically, now you have a server SDK that you code against rather than the way it was in mobile services where you were kind of sandboxed into what you had to do. So right now, as I said, we have a .NET Server SDK, and we will very soon have a preview Node Server SDK. Now let's see if I can show you the code now. Oh, it really wants me to log in. OK, I will do it. So what will happen at this point? OK, so there we go. It worked. So what I could do then is pick the code site. And actually, it's this one. And then I can publish to that. You can also download a publish profile. So if you have a bunch of web apps and you don't want to pick the right one, you can just import that into your project really easily. So let's look at this code here. What I have is a job controller, which represents those open cases that were in Salesforce. And this table controller is really, really similar. Actually, it's exactly the same. It's not just very similar. It's exactly the same as what you had in mobile services. Now, the difference is, of course, that you can host more things here. And I know some of you would get frustrated that you had to use particular versions of various NuGet packages and a particular version of Web API because we were hosting everything. And I can see everyone's very happy about that. So guess what? You can host whatever you want. It's all open to you. But you get those same benefits of the table abstraction that's in our NuGet packages. And here, if we look at the patch code here, I'm going to show you how I'm doing the write through and just the right part of it. So this part is exactly the same as what a regular table controller would do. And now I'm going to call the Salesforce client, which is the Salesforce connector. And I'm going to send a request to update this particular case that I'm working on. Now, the web job is also deployed in the same exact backend code site. And it is also using that same exact Salesforce helper. I just linked to that code file. And it has a long-running process that basically every 30 seconds polls and looks for new data. And that's how everything stays in sync. And so you may have noticed this stuff here. And this stuff is related to offline sync. So I'm going to start talking about that. So if you're familiar with mobile services, you know about the tables endpoint, which basically gives you a bunch of REST endpoints for doing all of your create, update, et cetera operations. One of the reasons that that's valuable, aside from the fact that it's a useful abstraction, is that you can use it to do offline data sync. It basically implements the protocol that our client libraries expect. And once you provide those additional properties, which, by the way, you can modify any REST endpoint to provide the right properties, then you automatically just have an endpoint that you can use with our offline sync SDKs. And so I probably don't need to explain to you why it's good to have offline sync. But every time I step into an elevator, I'm constantly annoyed at my phone because I lost connectivity for 30 seconds, and suddenly the apps think they can't do anything anymore. Now, the reason that apps don't implement offline sync is that it's usually really difficult to get it right. Now, the simple cases are pretty easy, like a read-only cache of data. But once you want users to start modifying data, and once they can modify data that's maybe owned by other users, now you get into a whole world of madness that's usually something most developers just don't want to touch. However, when you use Azure Mobile Apps and Azure Mobile Services, it's really easy to do this. Our SDK does the heavy lifting for you, but it still exposes enough hooks so that you can customize the behavior to suit your own needs. So why would you want offline sync? As I said, you want to cache data. You want to be able to handle intermittent network connectivity. The key point, the one that's really tricky to do, is that when you want users to create and modify data, even when there's no network. So remember the cable repair person, the one who's also an actor in his spare time. So Bob Johnson, when he's going to someone's house in order to repair their cable, chances are he doesn't always have a network connection. You as a business and you as a customer don't want him to not be able to do anything because there's no network. At the same time, you need to maintain security of what is happening. You need to maintain authentication. You want to make sure that when he makes edits, that those are reflected in the system as having come from his machine. And that's the thing. Those are the things that we offer for you. You can also use offline sync to sync data across multiple devices. If you have customers that can log in on a tablet, let's say, and a phone. And finally, most importantly, when there's conflicts, you can detect and handle them. And you can handle the conflicts on either the client side or in your backend code. And the way it works is that the client SDK keeps a queue of all of those operations that you've done that can modify data, so the create, the update, delete operations. And once you get back online, you can do a push action and send those changes. And at that point, it will detect conflicts. If you opt in to the versioning on the client and the server, you can get conflict handling and decide where to handle the issue. Also, a lot of times, records will get deleted from your database, and now clients are caching them locally. How do they know what to get rid of? And the way we implement that is with soft delete. So you mark a record as deleted in the database, or if you're using the .NET backend, for instance, you just change the response to include the deleted flag for those records. And then the client just automatically will purge them for you as part of its pull operations. And of course, offline integrates with other mobile services features, so you can use a push notification to trigger a sync if you want to. So let's go back to our exciting cable company, and let's look at the client side of it. The mobile client SDK is now going to sync its own local SQLite database with the Azure mobile backend. Now, this diagram, the part on the right, is really important from an architectural standpoint. Notice that it's not going straight to the database, and it's not going straight to Salesforce. That's really important because you as an app writer, you want to keep your client app code as simple as possible, particularly if you want to make it multi-platform. You don't want to think about where the data is located. You want a layer of abstraction for that. And by putting that layer of abstraction in your backend, you can decide what view clients see. So clients get a really, really simple view of things, and it makes it that much easier to write your client code. Because other than offline sync, having a nice, simple model for the clients means that you can display your UI more easily. You can have your semantic actions map better to what's in the actual database, and things just work out better overall. So let's see this in action. You're all probably itching for a live demo of this. So to do this, I'm going to switch to my Mac, where I have Xamarin Studio running. And you saw the UI of the app. What I'm going to do here is I'm going to build this up incrementally. I'm going to start with an app that actually has no data connection at all, and not only connect it to the mobile backend, but also add offline sync at the same time. And hopefully this will show you how easy it is to add these features to existing apps. So as I said, this is a Xamarin Forms app. It works on both iOS and Android. In this particular case, I'm just going to show you the iOS version. And what I have here is the service aspect of the class. And this is the part that returns the actual data. And here what I'm doing is I'm just returning mock data. So if I launch this in the emulator, iPad emulator, what I'm going to see is just some fake text. So yes, we have lorem ipsum and et cetera. So fake text. Let's quit that emulator out. So what I can do, I'll comment out the mock data, and I'll add an initializer to connect to my mobile service backend. And I'm going to use some code templates so that you don't have to watch me type everything. If you're familiar with mobile services, you'll see that this constructor is really similar to the one for mobile services. The one difference is now there's a gateway URI. Here I've put that into a member variable so you don't have to see the whole thing. But this is where all the authentication goes. Now, in order to actually store and later send these create, update, delete operations, I'm going to create something called a sync table. And what that is an abstraction that keeps track of these changes. And when you read from a sync table, you're reading locally. You're reading from your local SQLite database in this case. When you send updates, again, you're doing updates on your local database, but the SDK is also keeping a queue for you of all the changes it has made. Since I'm using a local storage layer, I need to initialize it. So here, I'm using a SQLite store. This is one that we provide for you by default, and is basically using SQLite in order to do the offline sync storage layer. This is completely customizable. If you see here, I'm initializing the sync context with this store. If I can pass anything that implements the right interface. So if you have your own local store that's based on CouchDB or some custom thing, you can just drop that in really easily. So I've been running this app a bunch of times, and I don't want to see old data, so I'm going to change this local store name. So then I initialize the local store, and then I initialize the sync table, which is basically mapping everything, wiring everything up with the sync context. Now, when I want to read what I'm going to do is I'm going to read from job table, and this particular method supports a search, so it's going to do a query on the local SQL database and then return the result. But this is all doing a local read, which is really important because you, as an app developer, you don't want to write really complicated logic to decide where to read from, depending on whether you're online or offline. Instead, what you're going to do is write code that works against the local store, and then based on your app's logic, you're going to decide at what point you want to synchronize the changes with what's in your actual mobile service. So this gives you a ton of control, and this also means that you can write apps that can either be in the primarily online mode, where they're just kind of keeping some state around just in case you step into an elevator, or apps like the field technician, where he might usually not have connectivity. So now, to update the job, I've already set its status to complete. What I'm going to do here is just call update async on my sync table instance. And if you're familiar with mobile services in the online SDK, actually, this is the exact same method call that you would write. Same with the query that you do here. And that's by design. Now, the UI is going to periodically call sync, particularly when you go from online to offline. So let us add that functionality here. This is slightly longer, but it's still pretty reasonable. First, what you're going to do is you're going to push changes that you have pending. If you actually pull changes and you have pending changes on that same table, the SDK will actually call push for you. That's how it makes sure that everything is consistent. Now I have a query, and basically what I'm saying here is I just want this app should only have those jobs that belong to this this particular technician. We don't want every single job in the world showing up. That takes up a ton of space, and also your UI is probably going to look really weird. And then what you do is you pull async with that same query. Here, the first parameter is something called a query key. And that's optional. Here, I passed null to it because I don't have a ton of data. What that does is it does incremental sync for you. It uses SDK as an internal table where it's keeping track of the queries it's done. And it keeps the timestamp of the last record it got the last time you did a pull operation. And so when you pass in that same query key, the next time you do a pull, it's going to start from that point and get everything later than that. And that's it. So fingers crossed, let's build everything and run it. So now what this is going to do is get all of the active cases. Let me open up Salesforce so that you can see what we actually have here. So we had a cable box fix for Scott Guthrie. We made sure that was fixed right away. He's the most VIP of the customers. And then my coworker, Matthew, and I are the ones that have some outstanding work to be done, the work that's been assigned out to a technician. So here, notice there's no data. This is good, because I started the app in offline mode. And so what this is doing is it's pretending like there's no network connection and doing a local read. When I turn this over to online, what that's going to do is call my mobile service and put all that data into my local SQLite database. And then you can make changes. So to show you that it really does work offline, I'm going to turn it in offline mode. And what I'm going to do is, as the technician, I'm going to say that this work was completed for me as a customer. But since I'm offline, if I go here and refresh the view in Salesforce, you can see that the case is still new. And let's go back online. Refresh just to be sure. And it's pushing the changes. It's going to push through to Salesforce. And you see now the case is closed. And let's say in the meantime, once the field technician has left my house, I call back and I call my personalized customer service valet, and I say, nope, everything broke again. It's totally busted. And so here, what I can do is reopen the case. If I can remember how to do that in Salesforce. So I edit. Oh, this is the contact in the wrong place. You can see that I'm an avid Salesforce user. So the case is closed. Let me reopen this. Let me do something here. I'm going to turn this. I'm going to keep it online. Sorry, I was going to generate a conflict for you. So this case is now reopened. And I need to say why it's reopened. And the reason is that I called. And you can see here my boss is the customer valet here. He's been making all these changes. He's moonlighting at Fabricam Cable in his spare time. And go back here and refresh, and you can see my appointment is still updated. So now let's simulate a conflict. Let's have the technician make changes, and let's pretend that he's offline for a long time. And in the meantime, the customer support person has actually changed that same record. So what I'm going to do here is, so I'm in online mode. I'm going to mark this completed again. The data isn't synced. Here, I'm going to go and edit the case and say that everything is broken. And I'll change the status to new. And save and close. Oh, just save. So the status is new. Let me go back to my simulator. And, oh, I guess it refreshed before I realized. Oh, I didn't actually mark it completed. I did not set it up correctly. Oh, no, I did. Sorry. I get confused with all of these names of people who are probably not actually requesting cable service. So as a field engineer, that might have been a little confusing. But what happened was, as the field engineer, I closed out the case. But before I had a chance to sync, the customer support representative had actually changed the case and changed the title. And you can see that these changes are now reflected in the field engineer's app. So you don't have a situation where the field engineer has just left, and comes back to the office, and now he's synchronizing, and now you overwrite, customer data, because that would be really bad. Let me talk about how the sync conflicts actually work. Basically, so remember this diagram of how the synchronization is done. With offline sync, you can decide where you want to do your conflict resolution. You can either do it on the server side, which is what I'm going to show in this example, or on the client side. And the way it works is it uses something called optimistic concurrency, which is a very fancy sounding word for don't lock the database while someone is doing a write. So basically, think old version control systems like CVS that would lock. I guess CVS didn't lock. Even older version control systems that would lock files because someone might edit them, to newer systems where they assume that anyone could be editing, and at the time that you merge back in is when you handle the conflicts. And so that's what we do here. Basically, suppose that the first device creates a new record with a value of triangle and version 1. That's how we're doing optimistic concurrency. We're keeping track of a field with a value that has to change each time. When we map this into SQL, it's the row version in SQL, but it can be anything that can be mapped to an HTTP compliant E tag. So now device 2 is going to get the new data from the server. Device 2 is going to change the value to a square, and so now the version is going to get incremented. It's going to send that change back to the server. So now the client is out of, the device 1 is out of date. Now, if it tries to change the same data to a circle, it's going to think it's on version 2, but actually it's not, because version 2 is what the server has. So at that point, the server says, nope, sorry, you have a precondition failed exception. And it actually sends that particular HTTP status code of 412. So if you trap the exception on the server, obviously the client won't see it. But either on the client or the server, you can handle the exception in the same way. So let's look and see how that works in our server code. So let's go back to the job controller. And I said there was a bunch of code that you didn't have to pay attention to. But this is how I'm handling it. Basically, the way the conflict resolution works, or one way you can implement it, is to kind of pretend that you're actually handling it the same way you would on the client. And so here, what it's going to do is it's going to try to update the database. And the database is where I have that version field set. And because it's a SQL row version, every time the data is updated, the version is actually going to increment. So here, what the backend does is it catches the exception. And if it gets precondition failed, the 412, then it's going to decide what to do. In this case, it's going to do a server wins. So it's just going to ignore the client changes altogether. And it's going to tell the client, hey, this is actually what the value is. In a more realistic system, you probably would log the changes, or maybe you would merge the conflicts together. But this is just a simple example of how you might do the conflict handling. All right, so to summarize. Offline sync, it's lightweight, it's composable, it works with a bunch of data sources, even more than we had before. So I showed you Salesforce, it also works with Dynamic CRM, it also works with more interesting sources like Mongo or any custom API that you have. And we have cross-platform client SDKs, all of them support offline sync. We have client SDKs across many platforms, some of which are cross-platform SDKs. So you can write your code in Windows native, or you can write it in whatever you want. And like I said, you can do either kind of scenario, either primarily online or occasionally connected. And as a developer, you can decide how you want to implement things. So in summary, Azure Mobile Apps is really mobile services plus app service. It's the power of mobile services running on web apps. And this means that now you can connect to API apps and SaaS connectors, but you also get a ton of hosting benefits that Azure Web Apps provides you. So as I said, all of the sessions on Azure Web Apps apply here. So most of them have already happened. There's one tomorrow that I recommend that you see, which is going to talk about how you troubleshoot applications. And there's also a bunch of ones that you can see the recordings of. And all of these things will apply to your backend code for mobile apps. And now, you may not know this, but you can try Azure Mobile App and Azure Web Apps for free. You get a subscription, a site for 1 hour, and you can actually renew it because it uses a social provider. So just go to Akka MS, try mobile app to try it out. If you want to learn more, you can get to our documentation at Akka MS, App Service Mobile, or tweet us. Oh, and one thing I forgot to mention, I was going to mention while I was doing my Xamarin demo, is that the Azure Storage team has very recently, as in yesterday, have pushed out an update to their storage NuGet and their preview NuGet that has support for Xamarin. So if you want to use Azure Storage with Xamarin and mobile services, or just Azure Storage with Xamarin, it all works. And that's a great way for you to store binary data and decide, actually get it down to your client without having to go through a REST interface. So thank you very much. And I believe I have time for questions. Let me keep the QR code up. And feel free to either ask or go to a mic. And I'm happy to answer any questions you might have.
Hello. Hello. I would like to ask about push notification, because for many scenario where the device, when it's subscribed to for push notification, it receives channel URI, and the channel URI has some expiration time, like 7 days or something like that.
Right.
And it's really unuseful for a lot of scenario of apps. So I want to ask if with rebranding or other will be this changed?
So, the channel. So that's a really good question. So you're pointing out that the channel URI for Windows Store apps it has a lease for like 7 days. This is not specific to Windows, by the way. All the push notification services have some expiry. Mm-hmm. What you need to do in your app, if you use notification hubs, all you need to do in your app is when your app starts, you just have to retrieve that channel URI and pass it through to notification hubs, and you'll get something called an installation ID, which will map to a logical user. With regard to the channel URI itself, that's actually a structural thing that's in Windows by the Windows notification service. Mm-hmm. But like I said, all of the platform notification services have this. So
but like a half year or year. So 7 days, it's not enough for me.
Oh, that's true. But I mean, the half year, I mean, when you're on that boundary, that's not great. But what your app is, I mean, every time your app launches, just get a new channel URI, send it to the notification hub, and it won't have duplicates. If you're doing the channel URIs yourself, then you have to manage it. But with notification hubs, it does it all for you.
OK, thank you.
Any other questions? Yes.
So does this mean that mobile services will die, definitely?
No. Well, what do you mean by die?
Disappear.
Eventually,
because it replaces the majority of things.
Eventually, once every single customer has migrated to Azure Mobile Apps, we will retire the service. I don't know when that will be. While we have customers, we're obviously not going to throw it away. But like I said, if you're not changing your apps and it's in production and you don't need these new features, you don't have to migrate. It's up to you. We're going to put all that new functionality into Azure Mobile Apps, and so there's incentive to move. And at some point after GA, I have no idea, maybe a year after GA, we would probably stop taking new customers for mobile services. But that's a long way off. I don't think there's definitely nothing to worry about right now, and there's definitely nothing to worry about even when Azure Mobile App GAs. It'll be long after that with a ton of time for customers to decide what they want to do.
OK, thank you. Great presentation.
Oh, thank you. Any other questions? Yeah.
Would like to know when I did summary false, what is the path I have to follow? Because in the store, the web
Right, so the question is, how do you get started with Xamarin Forms? Because in our quick starts, we don't have a Xamarin Forms quick start. So actually, we have a sample ready that I need to put out a link to that one of our writers wrote that's in the mobile services samples repository on GitHub. And that one's Xamarin Forms enabled. And eventually, by the time we GA, we're going to have the Xamarin Forms one. The sample that I was showing, I'm going to make available on GitHub as well. And so there should be a lot of good starting points for people who want to use Xamarin Forms and mobile services together. I will, let's see. This sample would be on my GitHub. There's a to-do list sample that's actually already up. And it's in the GitHub repo, mobile-services-samples. But basically, the easy way to find that is to go to github.com/Azure and then search for mobile when you get there. And then you'll see all the mobile-related repositories. Any other questions? Any plans for Cordova is the question. That is on our roadmap. We don't have a timeline for that. But as you know, we had it for mobile services. We're at the very least, when we GA, going to have that same level. The question of, and of course customers want offline sync in that, the question of when that will happen is still unclear. But by the time we GA, there's going to be parity with what we've already shipped in mobile services. Yes? Mm-hmm. Right. Right, so you're asking about mobile services and strings and serialization. I should talk to you about this afterwards. Yes, I know exactly what you're talking about. It has to do with OData and date time versus date time offset, and different versions of OData support different ones, and they're mutually incompatible. But I'll talk to you about specifically how you can work around that. And it's a really good point. We should put some guidance up on how to handle date times, because it turns out they're pretty common. Any other questions? So the question is the new offering Azure Mobile Engagement, which some of you may have heard of. It came from the acquisition of a company called Captain. And the question is that going to be an app service? At the moment, there aren't any plans for us to merge together. But obviously, what we're going to do is continue to listen to customer feedback and see what kind of features they want to see. And kind of, do they want kind of a particular tier that's geared towards app developers, like crash reporting, that kind of thing, versus mobile engagement. But right now, there aren't any plans to bring the two together. Anything else? Yes? So the question is that I had an enterprise SQL database. That one's actually running in SQL Azure. And then I have the local one on a SQLite store locally. And how do you transfer the data back and forth? That's actually all done through the REST calls on each table operation. The reason that we're not doing a bulk transfer, we do plan to support batching, though, where you can send a bunch of requests as one. The reason we do it as individual operations, though, is so that as the developer of the app, you can implement conflict handling. Because as I said, it's not a database-to-database sync. It's a database on the local device that's syncing with the protocol that you're exposing in your mobile app backend. So we're intentionally decoupling it, because otherwise what we would do is we'd build something that works perfectly for, say, SQLite or SQL CE and SQL Azure, and that's it. So there's been a lot of sync products that's all they did. And the goal here is to open it up completely so that you can choose what database you use locally and what database you use in your backend. Oh, so the question is about the enterprise database. How does it connect to the database on Azure? So there you have whatever options that are already in Azure. So Data Factory could be one. You can also expose your database using hybrid connections or VNet so that you actually you kind of are passing through to the enterprise database. But In terms of syncing the database to database, that's more of a question for the SQL team. I'm not completely familiar with all their offerings, but I believe there's some features that are in SQL Azure database and even SQL database running in a VM on Azure that could help with some of those scenarios. What we provide to you is a way of connecting through to that with hybrid connections or VNet or VPN, and then it's up to you how you want to synchronize that to an existing asset in Azure in terms of a database. Any other questions? Yes? So the question is, do we have a roadmap for OData Expand? We're definitely trying to figure out what to do with that, because Expand is really useful for modeling relationships, which I assume is why you're asking about this. So I don't know exactly how we're going to implement this. I can tell you right now we're looking at what our options are for supporting relationships. It might look like OData Expand. It might be something broader, but the goal is to kind of to provide that functionality. And right now, the OData Expand does work with the .NET backend, but on the Node backend, it doesn't, which might be one of the things you're alluding to. So what we want to do is basically make that scenario work. It may not be with that specific query operator, though.